Good morning, everybody, and welcome to the first ever Conclusion Unknown podcast. I am James Parker. I'm going to be joined in the booth. As you can see up there on the right-hand side of your screen is Mr. Craig Jones. Good afternoon, or good morning, Mr. Jones. How are you?
Hello, James. I'm very well, thank you. I'm really looking forward to finally getting this podcast done that we've been talking about for so long.
Yeah, we have. We've been discussing doing this for a very long time, and basically, what is it about? What are we going to talk about during this period of time? What is this podcast mainly aimed at?
So we're basically going to take conspiracy theories and theories that people subscribe to and talk about them and debate them. And I think this particular one that we're going to be looking at today is one that we've spoken about in little doses between ourselves, and we've had some interesting conversations around. So I'm looking forward to this one. So yeah, any conspiracy theory that's on the internet, we'll have a chat, we'll have a debate about it, and probably won't change each other's minds, but yeah, it is what it is.
You're never going to change each other's minds. Now, obviously, some of the things we've been talking about as well, some of the conspiracy theories that we've come across over the internet, and some that we're going to debate. We're obviously going to talk about the main one, which is the one we're going to start with today, right? Which is the Earth flat or round? We've also got lots of other conspiracies that we've been talking about as well. There's been more about 9/11. There's been Titanic suggested to us. There's been loads of different ones, and everybody in the community since we launched this, or we said about this, have come forward and said they want to talk about their own conspiracies. You know, we've got Morgan Butler who wants to discuss 9/11, and there's been a couple of others that have contacted us as well. Why conspiracies? Why are we doing conspiracies and not talking, I don't know, about sim racing?
I think it's a subject that we really everyone subscribes to it in one way or the other, don't they? So today in particular, you're either a flat earther or you're someone sensible like myself that knows that the Earth is round and it's a ball. There's either it's for or against, and there's a lot of stories out there that there's literally a massive divide subscribe to these ideas and people who just completely reject them. So I think it's something that everyone can enjoy and everyone can discuss, and clearly everyone wants to be part of as well.
Yeah, I think that's the thing that we're going to have to look out for, is everybody be, when we debate this, we talk about it in a way where we're not going to come out of it and be like, oh, I hate your guts, you silly fool, you bloody idiot, whatever. We've discussed this particular topic today plenty of times, right? Too many times that we've actually decided to stick it into the podcast, because, to be honest, this is one topic that drives me absolutely crazy. Flat Earth or round Earth? Where are you?
Absolutely 100% round Earth.
Okay. I'm not, which is no surprise.
Yeah, I know that.
Which is no surprise. Right. So let's get into this then, right? Tell us, right, over the period of years, there has been major debate across people about flat Earth, about round Earth, right? Now, are we living on a ball that's apparently floating in the space that contains water somehow, and spins at 66,000 miles an hour, and, tilts at an axis like this, and according to scientists, we're tilting even more, so at one point we're going to be round the other way in hundreds of years and whatever else, and, and then there's the people sensible who turn around and go, logically, that is not possible, right? Water can only sit at a level when it's in a container. We all know that, right? I run a bath. I don't sit there with an arch bath. You know what I mean? My bath's flat. I look out at the ocean and the horizon and the water's flat, right? It doesn't do this, because in my head, logically, right? Let's get into it while we're straight at it here as well. Logically, if we were round, right? If we were in this container like this is what you're proposing.
Yeah.
All the water would be down the bottom.
Right. Okay. Why?
Why?
But why is that? Why is that logical?
Because water don't. What if?
So
So
if
hold
you,
on. So hold on. Look, I've got my coffee. Right. This is my
yeah,
coffee, and in my coffee it's basically goes right up to here. Right.
yeah,
If this wasn't contained at the bottom by the bottom of my cup, where would my coffee go?
yeah. So what you're proposing is that the water is going to go around the ball and basically just drop off the earth.
Yeah.
Yeah. Okay.
Right. Now,
So
basically, if it was like this and we were covered in all of this water, it would just fill up like it does in a container. I did have a container here earlier, right? That like this, right? So look, this is off my wonderful coffee machine that my wife bought me, right? Now, obviously, as you can see, I've only got a bit of water in there. Now, if I put mass in this, the mass of the object will push the water up, right?
correct. I agree.
Okay, so to the point of where if I put more mass in this, it's going to push it right up to the top.
Yeah.
Now, I can only start with this. Now, a certain degree of our Earth is water. Actually, there's more water than land, right?
Yeah.
So if there's more Earth than there's more water than Earth, why are we not drowning? Why is the water not contained over the top of us?
But it is contained to a certain degree by the land, by the continents of Earth.
Are there how many continents are there?
7, isn't it? 7.
7 continents of Earth. Quick, have a Google. Right, I want to ask you another question. Okay.
Yeah, go on.
Okay, you are. I'm just checking, right? You are paying attention to me after all. Right.
I am paying attention to you, absolutely.
Okay, cool. Now, we've obviously had this debate
Many a times, yeah.
many a times, which normally results in me being right. Okay.
Yeah.
So tell us your side of it then, Craig. Tell us why apparently the water doesn't fill up the ball that apparently we're in.
But I don't understand why you're getting to the point of it's going to fill it up. So you're absolutely correct what you're saying with the water. So the land is the mass the mass object that you're kind of thinking of, and we know through science that landscape has shifted and changed over many thousands of years.
Mm-hmm.
So it's the land is higher than the current sea levels. So that's why the water is contained. What you're talking about is water draining around something and running off and falling into space.
Right. But obviously, if we're in a container, right?
Yeah.
How does the water get contained?
So to rephrase the question, you're asking how does the water stay on Earth?
Yeah.
So we have an atmosphere, we have gravity.
Theory.
The fact. Well, so why is gravity not real?
Because it's a theory.
But it's something that we can see acting, can't we? We can see if I pick up a pen and I drop the pen, it falls to the table.
But the pen's got no resistance. Is oxygen real?
Yeah.
Can we see it?
Well, so science as we know it, and I suppose one thing we've got to point out with doing something along the line of this podcast is science can only be ever as far as we understand it.
Yeah.
So when people say scientific fact, really it's not a scientific fact because it's only science as we understand it so far.
Yeah, it's basically the way we look at science is as layers, right? The more knowledge you add in to the layer, the more information you're going to get from it, right?
Yeah.
So science itself can sit there and say the Earth is round, but nobody can prove the Earth is round, right? If I said to you now, and no, listen, show me a true picture of the globe.
Right. Okay. So what about the space station?
Don't turn it round on me. I'm just saying, can you show me a picture of the globe?
I can't personally because I haven't had the privilege of going to the space station and taking a photograph.
Right, can you show me a picture off Google that's not CGI?
I'm sure if I Google, so yes, I could Google an image of planet Earth. I couldn't tell you if it was photoshopped or edited or anything like that.
Okay.
Of course I couldn't.
Okay, I can.
But that doesn't prove your theory, though.
Listen, no, it doesn't. Listen to this. Right, I've sent you the video earlier on, right, of my boy earlier on having a chat. Now I'm going to take the logo off the middle of the screen.
To NASA. And
so all I want you to do is just listen.
if you were to go to NASA and download one of their photos of the Earth in the moon sky and put it in Photoshop, you'll see that the Earth has been pasted in, because you'll see a rectangular box around the Earth. It's all fraud, it's all fake. The only one that NASA actually claims is a photograph. It was from 1972. Every other image is what they call a composite. It's Photoshop.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. It is photoshopped, but it's has to be.
Okay. The end of the video was the bit that made me more interested, right? This geezer here.
Picture. If you were to go to NASA, take a picture in various places around the picture.
The guy there works for NASA. He's a graphical artist for NASA, and basically he even comes out and said it's photoshopped. It's got to be. It has to be. What are we saying about that then? Because obviously from our perspective, that's made up.
But the video does state that there's at least one picture that is real.
Okay.
So
it's a composite. He said it's a composite. He put it into the computer.
You could. It's because it's on the video. It doesn't mean that it's necessarily true, though. Right.
Stop. Stop. Your words, and this is what every time people have said to me whenever we discuss this. Because it's your video, it doesn't mean it's real. Now listen, before you jump in, if, though, you showed me something like that and was like, it's on the video, it's got to be real. NASA produces images for you every single day that you go in your head and you believe are real. Why can I not sit back and go, that's real? Why is it your stuff's right and my stuff's wrong?
Okay, so I suppose one of the questions we've got to ask on not just this conspiracy or any of them is why? Why would we go to the lengths to not say the truth about the shape of the Earth?
Would you like to know?
Yeah, I would like to know, because I can't find any logical reason why.
Can you not? Right, I'm going to sort through my many tabs that I've opened up for this wonderful podcast, because I was sitting here this morning and I was thinking, right, what do I need to prove to you or anybody else listening that I might have a rough idea I know what I'm talking about? Okay. Let me ask you a question. When was NASA made? When was NASA?
I couldn't comment on that.
Can you not? I can. It's July 1958. Okay. Right. NASA was made in July in 1958. When was the Antarctic Treaty signed by all the countries that says we're not allowed to fly over Antarctica?
Again, I wouldn't be able to tell you.
I can. 1st of December 1959. A year later. Right? Yeah. When did the first image appear of Earth from Universal Studios?
Again, I wouldn't be able to date it.
You can't date it? Okay. Well, I can date it because Google's told me that basically Universal come out with their images long before we even knew it was a globe.
Right, okay.
Okay. So I'm going to show you basically a timeline of images from Universal Studios. There's the first one. You can clearly just see in the picture there's a globe there. When was that released?
I'm sure you're going to tell me.
I am going to tell you. 1913.
Okay.
Did we know at that point we lived on a globe?
Yes.
You sure?
100%.
Okay. What about that one?
Don't know.
Before any pictures, this one.
Right, okay.
1946.
Okay, but would it not be sensible to suggest that we knew what the land structures looked like by maps and stuff at this point?
What does this?
So if we knew that, that was a globe,
what?
Right.
Okay.
And we knew that that's what those particular continents looked like.
Yep.
Then it's feasible to come up with that image.
Okay. What does it make that image?
What does it make? It makes that image a mocked up image.
So it's a picture. It's
a picture, yeah.
It's somebody's.
But based on the
somebody's imagination. It's somebody's imagination.
I wouldn't say imagination. So at this point, we would have known that the Earth was round, and we would have known roughly that that's some of the land structures from maps and traveling, etc.
Okay, when was the theory of gravity?
Oh, again, I wouldn't be able to pull that date out of my head.
Okay, so Isaac Newton was apparently sat under a tree, and an apple fell next to him, or if you believe the reported story, it fell on his head, right? Yeah. From there, he determined that something's got to be pulling that apple down. Yeah? Okay. I'm in a swimming pool, and as you can see, I'm built like a robin redbreast, right? There's literally more fat on a robin than there is on me. I like weigh 12.5 stone or something ridiculous along those lines.
Yeah.
Outside of water, right, I cannot physically pick up a 40-stone man. True?
All right, yeah.
In water, I can pick up a 40-stone man.
Yeah.
Why?
Because the water's taken away some of that. So what I'm looking for, kind of the
density,
compensating for the mass of it, the object you're trying to lift. Yeah.
Yeah, exactly. So the density of the water is basically compensating for the weight of the man, right? So the density of the water is heavier than the man. So I'm able to move the man through the weight load.
Yeah.
Yep. Okay. The apple is denser than the oxygen and the air around it.
Yeah.
Okay. If I stuck that same apple in a consumed chamber with helium, which, as we know, is a higher density gas than oxygen, would the apple float?
Well, going back to your swimming pool theory, then yes, it would.
Right, it would. Do we not feel then that the apple is denser than the oxygen, so therefore it weighs more, so therefore that's why it fell out of the tree?
It's possible.
Okay, so when I put it like that, go on.
But what you're suggesting, you're looking at a very specific kind of element of Earth.
Logic.
So if you then go past Earth and you look at the solar systems and the universe in general, then gravity starts to make a lot more sense.
Okay, but we haven't been to the moon, but we'll discuss that in a further podcast down the road.
Oh, yeah, I'm sure we will.
Because that's another one that makes me really interested. But what I'm saying is...
Okay, so let me ask you this question.
Go on.
Let me ask you this question then, right? So do you believe planets exist?
Do I believe planets exist?
Yes.
Okay. Yes. I do believe that there's things... Right. Okay, so when I look at things logically, I'm a believer that we ain't the only ones here. Right? We can't be.
Too, yeah.
In the area of that's outside of this Earth, whether it be a ball. Now, I'm going to end this podcast with some information that's going to blow your head, by the way, as well.
Right, okay.
So whether or not we live on a ball, whether or not we live on a disc, whether or not we live on whatever, it don't really matter. Outside of this, we are not alone. We can't be. We're just physically not. Okay.
I completely agree with you.
So outside of this, that I also believe that we haven't been to, but I will discuss that later on further down the line, that there are other things out there. So now, regardless of what we sit back and think regarding the sun and the moon and all of this other fancy jingle jangle rubbish, right? what we're trying to depict here is, for me, I'm a very black and white. It's not black. If it ain't black, it's got to be white. There ain't no grey. Now, logic tells me that everything we're told about the shape of the Earth is made up 100%. Now, logically, images like the ones on the screen that people go around believing at the end of the day from universal pictures of the globe can't be physically true. Now, one of the reasons I say that is because these images were out before anybody knew what the shape of the Earth was about, right? That one's a little bit more recent, so that might be. But these ones back here, they have no idea. They're just making this up as we go along, okay? They're making these images up. They're literally, somebody sat there. Now, the video that I showed you earlier on of my guy there who turned around and said, the Earth's fake. It's got to be CGI because it's got to be. Why has it got to be CGI? Why has it got to be a composite? Why has NASA? Why do NASA need graphical artists if we've got this such powerful telescopes in the Hubble that apparently produces images of the Earth?
I think you're looking at very technical aspects of how they would take a picture, though.
Answer the question. Answer the question. Why do NASA need a graphical artists if there are images of the ball? This ball.
I can't answer that question because I don't have the technical know-how of how they would take a photograph or what technology they know. I know there's telescopes up there that work on all sorts of infrared and bits and pieces like that builds these images.
Right.
So it could well be that they use that to enhance the images so that you can see it. I do astrophotography, so I can take a picture of these various kind of objects in the sky, but I then need a computer to then bring out that detail so that I can see it better.
Okay. What's that?
So you're showing a picture of Saturn.
Saturn.
Yeah.
Okay. So we could take such detailed images of Saturn.
Yep.
That apparently we need CGI or graphical artists to determine.
Okay, so this leads me on to a perfect point, which is why I actually asked about why do you believe in the planets?
Okay.
I own 2 telescopes, and I can go out tonight. I can set my telescope up, and I can focus it. So the easiest target in the sky at the moment would be Jupiter. I can aim it at Jupiter. I can look through my eyepiece, and I can see Jupiter nice and clear. I can even see its moons, 4 of its moons, depending on the time of day that you look at it. That's there. That's in my eyepiece. That's not fake. That's not someone holding up a picture in space.
Okay.
That is a planet that I can see with my eyes, and I could take a picture of it, and I would get I wouldn't get an image quite as good as that, but I could get an image of it. I can see it. It's there. It's physical. There's even software. I can use a program called Stellarium, which will tell me at what point and what time that planet will be in the sky and the best time I can view it from.
Okay, cool.
Because it repeats itself.
I'm glad you've said that.
Okay.
I'm glad you said that, partly because that planet is behind us, according to solar system heliocentric model. The battery
goes backwards.
It's backwards behind us, right?
Correct. Okay.
We can never see that image if it's in front of us. True.
Why wouldn't you be able to see it in front? You can see any of the planets through a telescope.
Okay. It goes around the other side of the sun. We can't see it, right?
Yeah, unless something's blocking it.
Which is the sun.
Yeah.
Okay. So we can't see it in general. Right? If it goes round, so what I'm saying is that's the sun. Okay?
Yeah.
I'm going to use my finger. This is Earth, and then behind that is Jupiter.
Yeah.
Okay? At night, this side of the Earth can't see Jupiter, right?
Yeah.
Because it's because we've got the sun here. So when Jupiter then buggers off and goes right the way around the other side of the sun, so let's not do that version of it, right? we can't like, we can't see it. Do you agree? Because it's around the backside of the sun.
Correct. Yeah. You can't see through the sun, can you?
No, you can't see through the sun. We can't see it in general. We've got all this made up information about the sun anyway, but we'll discuss that in a minute. Venus and Mercury.
Yeah.
How do we ever see them? They're in front of us in the solar system, and I'll try and bring the solar system up, but it's going to be very squished.
So you can see Venus.
We can?
Yeah.
When?
You can actually see it with your naked eye.
Okay. When can we see Venus?
Only at certain times of the year.
Certain times of the year. Why only at certain times of the year? I'm trying to bring that image into picture.
Of the orbital spins of how we act. So that's obviously that's a straight line, but it's not necessarily how the planets behave and what time of the year.
According to the world, according to scientists that apparently give us the ball, we spin.
Yeah.
They spin.
Yeah.
The sun spins.
Yeah.
The moon spins. We all spin. But at one point in my evening, I can walk out and see the same constellations I saw the night before.
Correct.
Why?
Because we're spinning around the sun. So
hold on. So you're saying we're doing this rapidly? Yeah. How fast do we spin?
I can't remember the figures, the exact figure on it. It's very quick, anyway.
Okay. It is very quick, right? So apparently we spin around the moon, yeah, give or take. 460 meters per second, right? The Earth rotates once every 23 hours and 56 minutes and 4.09 seconds.
Yeah.
That also brings me into the next equation as well. Right, so we're spinning at 460 meters per second. Yeah?
Yeah.
We are literally full-blown fucking rapid.
Yeah.
Agreed?
Yeah.
The moon is rapid. The sun is rapid. But at any one point, we line up like that and we stop. And I go, oh, I can see the star that I saw yesterday in exactly the same place that was there yesterday.
Yeah, because
what are the chances?
So there are certain constellations you can't see in the sky at certain times of the year. So at the moment we're in winter here in the UK.
Mm-hmm.
I'm seeing the winter constellations. In the summer, I can't see the winter constellations.
Okay. Do you ever see the Southern Cross?
No.
Why not?
Because it's impossible because I live in the Northern Hemisphere.
But you said there's constellations and we see winter and summer. So why doesn't the Southern Cross go round as it rotates, comes upwards? Because I'm a little bit confused because we're doing all this really quickly. You know what I mean? And we're tilting even further, apparently. We're tilting like 1 degree per whatever. So slowly we're going to end up doing a full circle. And then I'll be able to see the Southern Cross in a million years.
We'll be dead by then anyway.
I know we will be, but in theory...
we would have crashed into Andromeda. We got bigger problems than that.
Well, look, according to everybody, you know what I mean, right? So we're doing this. Apparently we're changing degrees, right? We spin, yeah? Now, this has got something to do with the last thing. 23 hours, 56 minutes and 4.09 seconds. That is our day.
Yeah.
Now, I watched a video from Neil deGrasse Tyson, he's the god, apparently. He knows everything. He knows jackal. He ain't even left Earth. He's just making things up.
Scientists in the world.
And he's just making shit up as he goes along. I dreamt the other day that the Earth was a ball. And I woke up and I went, no, that's a nightmare. That's an absolute nightmare. He can't. So what I did, I watched a video from him because I thought, look, to come into a debate normally and sensibly, I've got to know both sides of the argument, right? Now, I know full well that if I've turned around and said to you, have you gone and looked at my side of the argument, what would you say?
I have.
You have? Good. Right.
Well,
I watched this video from Neil deGrasse Tyson, who turned around and said, we go round, right? 23 hours, 56 minutes, and 4.09 seconds, right?
Yeah.
Then we stop. And apparently, this is the best bit.
What do you mean we stop?
No, listen to this, right? He said, we go round, and then we get to these 23 hours and 56 minutes and 4 seconds, and then the sun does this. So we're going round. And that's where the other 4 seconds or something comes from. So at the same, this is going to blow your mind, right? At the same time we're doing this, we're also doing this, and then at some points, do that, right? Because we just turn our head just a little bit to make up for the 4 seconds that apparently we then declare that we go round 24 hours. Agreed? Yeah. So that apparent look back takes us 4 minutes. So now, so this is where it all gets a little bit confusing.
I know which video you're referring to. I've seen the same video.
Right. So apparently, we're doing spinning like this, and we're doing, actually, to be fair, technically, we're actually doing that because the Earth's on an axis. Yes?
Yeah.
So technically, when we're spinning, when I get down here, because at some points I'm going to be down here, right, throughout the day, yeah? Because if the Earth can't be on an axis and spin like that. It just, logic doesn't tell you that. So the rotation of the Earth should be like this. So at one point, I can see the Southern Cross in the sky, and then I'm going to see the Northern, and then I'm going to see this, because I'm going to be up and down from the hemisphere. Because if the axis of us is like this, right? That's where we're at, 24.9 degrees axis. That's what we're on at the moment. So technically, we rotate like this. Yeah? Agreed?
Yeah.
Okay, we're rotating on the axis.
Yeah.
So if I'm in here, when I go round, I'm going to be down here. And then I'm going to be back up here again. And then I'm going to be down here again. Because that's how it works. You can't have, I'm trying to find something now, right? You can't have something that does this, that at some points I'm not going to be upside down. It doesn't make sense. Your turn. You're up.
So in your made up fantasy
so now we're going to start that, are we? In your made up world, where apparently we live on a fucking globe.
Hang on. All you've done
is produce science.
How's any of it science?
Oh, sorry. Let me just rephrase that for you, because you'll understand this one. All I've produced is theory.
Right. You've just produced. All you've shown me is a video of someone saying some words and some pictures of planets and
but
solar systems.
According to you, if you show me a video, it's true.
And this is my exact point. We knew that the Earth was round years and years ago. Like, you're talking thousands of years ago. We worked it out by basically looking at the stars.
Right.
To understand. So in your theory, so what you were saying before, you're contradicting yourself, because if the Earth was flat, you would be able to see the North Star and the Southern Cross.
The Earth, what I'm saying is if now I'm going to bring you a conclusion at the end of this, right? And I'm going to prove something to you as well. Whenever we see images of space, right? Whenever we see images of the Earth, first things first, we're looking for a round window that's layered. Now, when it becomes layered, you get this fisheye effect that automatically brings the curve, right? Let's be honest. And we're always looking down. We're always looking down. Now, what I want you to do is, I don't know, have you got a cup or anything?
No, not really.
Right, okay. So this is my little model, right?
Right, okay.
So we're always looking down at the Earth.
Yeah.
And the Earth always looks like this.
Yeah.
Right? Curve, yeah?
Yeah.
But we never see this.
No,
ever.
Because because whatever angle, that's always going to look like that.
We never see it, do we?
I take your point. It doesn't mean it's not there.
If we were here, if we come down here, we'd be looking up at the Earth, right?
And it would still just look like a round.
But we'd be looking up at the Earth.
Yeah.
Okay. So we're looking up, which therefore then makes it, when you look up at anything, if I just show you that, it makes it flat. You think flat earthers, and there are some crazy cuckoo. No, listen, you think there's some cuckoo flat earthers out there that believe that we're just this, right? We're this.
Yeah.
Okay. Physically, even in my head, and I'm a person who's debating the ball, right? I don't think any of this. We never see this. And there's a reason you don't ever see this.
Why is that then?
What shape is the Earth?
It's a ball. It's a sphere-shaped object
Wrong.
in space. Why?
Why? Okay. Now, I'm going to go and sift through my mountains of information that I found out earlier on. Right?
So is the moon also flat?
We don't know. We've never been there. That's just another made-up bunch of rubbish. Do you know what I mean? Because, no, listen, because you're always looking at something like this. You're always looking at something in a circle. You
Correct,
never
yes.
see. Now, listen, you never see, whenever you're looking at something like this, for all you know, it could be as thick as my lid.
Yeah, I take your point. Absolutely.
It could be as thick as my lid. We never get far enough away because we can't even enter space or the outer realms of space. And that's what makes me laugh. But we'll cover that. We'll skip it. No, go over that one because that's a different podcast altogether because I am loving the space podcast. What we got coming up, right? We only ever see this. We never see the complete ball, right? Do we? Do we ever see the complete ball?
No, and you never will.
Why?
Because it's physically impossible. If you look at any ball, you're only ever going to see a circle, like a flat surface on it.
Sorry?
You can't see.
Sorry?
It's always going to appear like a flat surface. It's a circle. That's just how it is. Doesn't mean that it's not there.
A flat surface.
It's going to look
like a.
I haven't got a ball to hand, but whatever angle you look at the ball, if you take a picture of it, yes, we can emphasize 3D in our heads, and that's how our brains work and stuff like that to know that it's a 3D shape. But to take it on face value, it's a circle. But the shot you're looking for, you're never ever going to find because it doesn't work like that.
No, it doesn't,
So
because the graphical artist can't give you an impression like that anyway. Let's be real. It can't be made up on NASA's computer. You know what I mean? And I've seen some terrible footage, right? Absolutely horrendous footage of NASA's green screen effects and their hairspray hair. I love their hairspray hair. But we're debating whether or not the Earth's flat. Now, apparently, according to you lovely globers, and I call you globers because if I gave you the correct term, it would be globetards, because that's
sensible, logical people.
You're not. You're indoctrinated into the news that you're believing everything. I suppose you're going to believe that the government's going to make this world great as well. But look, I'm sure that's a different story once again. What is what's the curvature of the Earth?
Just to make it clear, I'm not a scientist.
You're supposed to have this. If you're going to a debate with me, you got to have all this information. What's the point of having a debate if I've got all the
I don't
information?
need to know what the curvature of the Earth is. I just know it's curved.
Okay, you know. Why do you know?
Because you could see it.
Because you've been told.
No.
Because you've been fucking told that you could see it. You've been told that you can see.
Every single I've come into this debate basically. I was, I'm not interested in showing you any video or anything like that. That can all be created. I can go up and I can set up a website in seconds, and I can put whatever nonsense I want on there. And it's on the web, it's on the internet. Google says it's there, so it must be true. Right. You can see this stuff with your own eyes. Like I said, the telescope. I can go out every single planet I can see, and they are all circular shaped. I get what you're saying with your little lid and
little lid.
You're never going to get that image, but what you can see is all the planets are round. So that's got to be suggestive that Earth is also round. You can see the moons going round it, which shows gravity. That's the theory of how everything works. The bigger the mass, the stronger the gravitational pull.
But you're basing that on an apple.
But it makes sense, though.
Why does it?
Because of course it does.
Okay, I'm heavier than the air around me, but I'm still keeping my ass on the chair.
Yeah, but okay. So if you take something like Jupiter, so Jupiter is huge, way bigger than Earth, right?
Yeah, it is.
So why doesn't that just fall away? So surely, what's holding the Earth up? What's holding all these planets up?
Right, according to scientists or spacemen or made-up little aliens, we're constantly moving around like this.
Yeah.
We're doing on a tilt like that. Everything around us, and it almost looks like a spiral because we're constantly going up, right? Because we're spinning, and we're just spinning, and we're just spinning, apparently.
Yeah.
Okay? Now, none of us, and I'm going to say this in the most graphical term ever, none of us have ever been to space. Right? Now, when you look at the curvature of the Earth, okay, apparently it's 0.08 meters per kilometer.
Right, okay.
Okay, so if I calculate that from... How far do you live away from me?
What, distance-wise?
Yeah, hold on. Let me just crack that one up. Maps. Let's see. You live precisely hour and 10 minutes away from where I live, right? So that equates to how many miles? How many miles does that say? It'd be nice if you could give it to me in a car. That would be better.
70 something, probably.
70 something miles. So we'll call it 70 miles. Okay?
Yeah.
So let me just check. I've got to do me miles to kilometers. Miles to km calculator. So 70 miles, 112 kilometers. Right, so 112 into me little Earth curvature calculator. No, let's put the full figure in. 112.654. Right? You are 1,000 meters below me.
Yeah.
Are you sure?
Well, unless I went out there and measured it myself, but that sounds logical to me.
Right, so you're looking up at me.
Potentially, yeah.
Can you see me? I'm waving.
No, I can't see you.
All right. How far
Because
can your eyes see?
I don't know.
You can't see.
So
people tell me, and this is the thing, I had a discussion with a guy called Jimmy, who he knows who he is, and he's going to be watching this back, sitting at home crying. He's turned around and said, why can't I see Mount Everest? Do you know what... Now, I watched another video from Neil deGrasse, I'm a Superhero, and he has, the fact that Everest is the highest peak on Earth, right?
yeah.
Because it's so many meters above sea level. Agreed?
Right. Yeah.
Well, at the end of the day, my eyes can only see so far. And I wear glasses, right? Because if I go like that, you're blurry. Why is what's been the question given to me? So I'm going to ask you this question, but I want you to answer it. Why can't I see Everest in general? Now, the higher I go, why can't I see Everest?
Right. I found something. I found something to use. Right.
Right. Now, answer my question first. Why can't I see Everest?
I'm gonna explain it to you.
Okay. Cool.
Right. So you're saying, I don't know if this is actually going to work. So you're saying with the distance between our houses, you're slightly higher than I am.
You're 1,000 meters below me, apparently.
So there's you probably won't be able to see it. I put 2 marks on there, right? So if I'm down here and you're say up here, slightly exaggerated, I know, I can only see whatever the straight line is that way.
Right.
So although you're higher, you're further around the curve, aren't you?
Okay.
So the curve's further down. So that's why I can't see you. That's why I can't. But that also contradicts the argument about flat Earth, because if that's the theory, we have powerful enough telescopes and binoculars and stuff, we should be able to see other countries, but we
Okay.
can't.
No, we can't. I can see the Isle of Wight.
Why is that? If it's flat, why is that?
Okay. Why can't we see things? As you look further out, right, your eyes can only see so far, right? It's like now, if I look out of my window, I can only see so far because I've got houses, buildings, dirt, dust, all these other particles in the earth that blur the vision of me being able to look so far. Even if I looked in a telescope, I would have the same problem. I can only go so far because my telescope would only see, due to the fact that I've got hills in the way, and there's, roads, there's houses, there's chimneys, there's all of this stuff in the way, right? On my flat plane. Yeah. So I might be here and I can't see because obviously I can only see so far. Now, people are saying your Earth sight is infinite. We can see everything, but we can't. And I do debate this with people because of the fact that we can't see everything, because I can only see so far out of my house with the fact that I've got a hill in the way, and I've got houses, and I've got dirt, and I've got dust, and I've got heat haze, and I've got pollution, and I've got all of these things that don't allow me to see that far. If I go up in a helicopter a little bit higher, I can see a little bit further. But again, the higher you get up, there's pollution, there's dirt, there's haze, there's everything, and I can't actually see you completely. I go up a little bit higher, it's like anything. I can see a little bit further. And higher up, and I can see a little bit further, till the point of where I can get to a high enough level where I can see the south coast where you are. Okay? Yeah. That's how it works. Yeah. My eyes aren't infinite, and I know there's people at home that will go, your eyes are infinite, you can see everything. No, you can't. Right, and do you want to come and have a debate with me about that? Come, jump on, sign up. You know what I mean? Because that's just crazy. I don't wear glasses because I can see everything. So, and you've got to look at that area. Now, when you go up in an aeroplane, all right, and I went off to Spain in May, as you know, me and the wife jumped on an aeroplane, leaving on a jet plane, and I looked out, right? And we were cruising at 36,500 feet, just give or take. Right? Agreed?
Okay, yeah, that's what planes do.
Okay, and I looked out the window.
Yeah.
Now, I don't fly very well, right? I need Valium to get on an airplane. I don't like it. So I looked out the window as my fault. I've got to do this because I've got to look out the window. My horizon.
Yeah.
And I'm up in the air, 36,500 feet. My horizon was flat. Why was my horizon? If I'm going 0.08 meters, and between me and you, there's 1,000 meters, right, which is quite a far drop. Let's be real about it. Why was my horizon straight and everything I'm not looking at peeled off like that?
Because the Earth is so big. There will be a gradual difference on that straight line. Flat earthers have even gone out and tried to prove that and ended up disproving it by doing the ludicrous experiment they did.
But they've done it with
that there is a curve.
They've done it with lasers. They've done it with lasers across a certain amount of distance. Between me and you, and we're only talking 72 miles, between me and you, I'm 1,000 meters above you.
Right. So what about the oceans? So you're saying about like you can't see hills and stuff like that.
No.
What about seeing a ship that's sailing away from you?
Yep.
On a straight course, eventually you won't be able to see the bottom of the ship.
I see. Now I figured
why is that?
Okay. Now I figured you're going to come with me at that one, and I sat here and I thought, you know what? I could sit here and say to you, objects. Look, the further away the object, the more it decreases in size. Right?
Yeah.
Now, if I put up a drone up in the air, right, like that, I put a drone up and I kept it at 200 meters above me, yeah? Sooner or later, look, so if I go, look, so I put my finger on my mouth and my finger on my glasses, okay?
This is going out on the internet, you know.
Yeah, I know, I don't care. This is James Parfitt science.
It's fine. You don't look ridiculous at all.
I don't really care. You know what I mean? Whatever. So as I'm moving away, sooner or later, it's going to look like my two fingers meet.
Yeah, of course. Yeah, I agree. Yeah.
Yeah? That is what the perspective of your ship is doing. Why I'm looking... Yeah, but dude, if it's doing this, it's going to be upside down by the time it gets to Australia.
Why is it the bottom that I'm not seeing?
Because it goes out of sight as it comes along. And the bottom's going to disappear first.
You can't see the bottom of the ship because it's going over the curvature of the Earth.
It's just getting further. It's just getting further away from you.
You can see it with your eyes.
This is
all stuff.
Oh,
I don't
my
need
Jesus. Stop.
I don't need a fancy slideshow or fancy pictures.
I literally used my finger.
This is stuff that you can see with your own eyes.
My finger is the same level, and now I'm below the bottom of my own finger.
Why is it that the southern hemisphere sees a different sky to the northern hemisphere? In your made-up world of a flat Earth, the sky would look the same wherever you went.
I'm glad you got there. We're getting to the end of the podcast, right? We said an hour, although we could be here for absolutely ages.
Days.
You could be here for days. And literally, we both agreed that at any point when we talked about this, that neither of us could be right. Okay? None of us, at the end of the day, me and you have agreed that none of us could be right because of the fact that I haven't been to space, you haven't been to space, and we believe the load of made-up rubbish that's given to us from the internet from 100%. Both parties, right? Both sides. Yep. Flappers and globers or tards or whatever they call us. I don't care. Now, I'm going to show you an image. Now, this is...
here we go.
No, listen. This is the bombshell. This is the bombshell. Right. No, this is going to be the absolute bombshell, right? I need to get the image into the picture. Although I did set this up earlier on as well. Right. What is the shape of the Earth?
It's a globe.
It's not a globe.
It is.
No. The shape of the... Listen. The shape of the Earth. As we all learn earlier in school, the Earth's shape is very close to a sphere, right? Pictures taken from the bottom of a swimming pool in Houston, turns around and tells us that it's a globe, right? Neil deGrasse Tyson come out on a video and he said the shape of the Earth is more like that. Now, to you, that looks like a ball. On my screen, it doesn't. So basically, it's a ball.
It's a bit
squashed. Yeah, squashed. Yes. Right, so that ain't a sphere because a sphere is a ball. Just pointing at.
It's very close.
No, you're just making up. No, it's very close to being flat.
There is. You're talking. You're not talking.
Is that very? Yeah.
It's
if I went like that, it's flat.
It's slightly misshapen, James. It's
not. According to this,
do you know why that is?
Oh, because apparently, now this is where it all gets wrong. Apparently, water that sloshes like this is affecting the rotation and pushing the water out because it's in this magical container. Am I wrong?
But what's causing the water to do
Tell
that?
Me.
The moon.
The moon that we haven't been to, that we're just making up stuff as we go along.
So again, because we haven't been to it, it doesn't exist. In your head. I'm not saying that we haven't been to it, by the way.
We have. Can I just ask you before we go into this podcast next week? Did you see the Japanese moon landings and the Indian moon landings? I'm not being rude. I can make better airplanes in Roblox. I'm just saying. Right? That was about as fake as it could ever get. No, hold on. So let me get back to my little demo because this is my little bombshell. So the Earth is squished, right?
Yep.
Okay.
Ever so slightly, yes. You are.
No, not ever so slightly. Apparently, according to Neil deGrasse Tyson, it's like this. It's more of a opioid, not an opioid. What did I look at? The opioids. Isn't that a poppy and it's like drugs or something?
Yes.
It's more of a poppy-shaped cocaine addict. It's for God's sake, what's it called? It's not a sphere. It's an oblate spheroid. All right. Again, me and my useless information. There you go. It's an oblate spheroid. Okay.
Yeah, it's a type of sphere. Let's go with that.
Oh, you're still wrong. But anyway, right. So it's a spheroid thing, which is this shape. Right.
Right. Okay. Yeah.
Okay.
Yeah.
Now, I'm going to show you something. Now, if that puts the poles in the middle, right? And the reason I say that is, look at this. Right, I'm here in London.
Yeah.
Right, that's London. Well, that's England. And do you know the interesting thing? If you Google Earth images from space of the UK, there's hardly any. And I'm going to fly to Los Angeles, which is over here.
Yeah.
Yeah?
Yeah.
Okay, cool. Now I want to show you something else. This is a depicted image. Now I've got to find the tab. Hold on, I've got so many open here at the moment. This is one of the images of the original Earth, right? Hold on, I'm going to try and zoom out and I'll move it into picture. So there he is. Right. As you can see around here, that's the ice wall that we are actually contained in. In the middle is the pole, right? And I'm not joking. I'm going to show you the pole. There is the pole in the middle, right, of this wonderful thing. Now, after watching all of that, so after watching about the fact that my little Earth is this shape, right, I Googled the most accurate map or the current map that is depicting a flat Earth. Okay?
Yeah.
Okay. What do you think I ended up with? Apart from the fact that I ended up with a cartoon because somebody drew it. Go on. It's the same as your NASA map. It's made up.
But have you not got this map then?
Yes.
Okay, let's see it then.
Right.
Right. Okay.
That is apparently. Now let me get this into the picture as well. Now that's the image. That's what I've actually got. Okay. There's nothing on the edge there as well. As you can see, this is it. This is the most image. This is the image that apparently the most accurate flat Earth. Right.
Yeah. Okay.
Now I am in London, which I'm now up here. Because apparently I'm upside down now. Because, I'm spinning so fast it moved on the screen. And I'm going to fly to Los Angeles, which is over here. Okay?
Yeah.
Okay. Now, for me, the quickest way would be straight over the North Pole, because that's at the top, right? So if you imagine we're looking down on it, okay? Yeah. Straight over the North Pole and off to Los Angeles.
Yeah.
Okay. So I thought, right, what am I going to do now, apart from Google the flight path from Los Angeles from Los Angeles to London. Okay. And this is what when I can get it to come up. Come on.
I know where you're going with this.
Yeah, you are. You're right. So there is the flight path. Yeah. Okay. According to this version, right? Because let's be honest, I don't even know if this is real. This could be made up as well. Now, the flight path, according to you guys, I would be setting off around here and coming down here because I'm on a globe, so it makes more sense for me to do that.
This is direct.
Yeah, on my route, it would be from here to there, so it would be direct, but we go over here, which is up, right?
Yeah.
Up. So we go up.
We don't go up.
From London to Heathrow, you can see it there. It's on the map. We go up. We go up and over. That is a direct flight path from the gcmap.com. Yeah?
Right. Okay.
So we go up. Now, on my most recent flat Earth map that you dismissed, we go up.
Yeah.
But we don't on the flat Earth map. We go across, which takes exactly the same path as your map. It goes over the tip of the pole and then comes down.
No, it doesn't. Go back to...
I'm literally looking at it. That's the flight that's the flight path, right?
Right, okay.
That is the most recent flight path from Heathrow to LAX.
Yeah.
Okay. So now I'm going to go on to my map and I'm just going to put this over here. You can't... So here I am, London.
Yeah.
Los Angeles. So I'm going to come this way. I'm going to go over the tip, which, if I can get both of these pictures into this screen at the same time here, you will see how I'm going to run this. So hold on. I'm just going to try and do a little bit of trickery here as well. Ow. Where did it all go? Hold on, I've lost everything. So, at the end of the day, right, I should be back now. Hopefully I'm not paused in that horrible image. Am I paused, Craig?
You're not paused my end.
No, but apparently according to the screen, it looked paused. According to my camera, I'm a bit paused. What's going on up here? Oh, hold on. Let me see if I can get this back up. Hold on. Because at the moment, I'm like that. For some reason. I look really quite bizarre. Hold on. Right, there you go. So, you know, according to the flight path of Los Angeles, which is this one.
Yeah.
Okay, let me just get rid of some of these tabs. I've got more tabs than I care to imagine. Right? So this is it.
Yeah.
Now, according to my most recent flat Earth map, and now I'm going to try and get these in the same picture. I don't know if I'm going to be able to. Right? So there we go.
Yeah, I can see those. Yeah.
Yeah? So I'm London Heathrow. I go up the tip of the pole and I come down this way. Yeah? Yeah. I'm on a flat map, the most accurate flat map. And I'm in London and I go across the tip of the pole and I go to Los Angeles. It's a straight line, right?
Yeah, but it's not the tip, is it?
But it's a straight line, right?
You're taking more of it. That, are we not talking about the arc in the Great Circle map of one that I can see? Is that not the arc that the flight takes? So it goes.
You're
saying it actually does that. Is that not what that's depicting?
But I wouldn't do that
motion rather than that motion.
I wouldn't.
Why would the plane choose to go around that way?
Because it can't go this way. Why doesn't it choose to go this way? Which it should do. If you're going round something, it should go like that.
Why is it going round? So that's
because we're on a bloody ball, according to you. Of course, it's got to go round it.
Yeah, but you're talking about the direct flight paths with land masses and bits and pieces.
Why do you think? Okay, I'm going to give you an idea. Why do you think an aeroplane heads over land?
Well, maybe for safety reasons.
If it crashes over water and I drown, my family's going to sue the rubbish.
Yeah.
Right.
Yeah.
So, okay. So this is why this doesn't go down this way. Even though it would hit land about the same point it does up there. Okay, so it doesn't go in a straight line, which should be like literally across there. So it means it actually hit land earlier than it does. Okay, but it doesn't. Yeah. It goes up from London Heathrow. It flies up. It goes over the top of Dublin, goes up, touches the top of, I think that's Greenland up there, I believe, comes back down, and then it's in through Canada. Now, if I bring you up the most recent flat Earth map, and London's up here, so maybe you can see that. I'm going to go over the tip of Greenland or the pole or whatever that is at the top there, and I'm going to come straight down to Los Angeles.
Right.
Through Calendar. So I've taken that side, that route, but mine's flat. If I'm on a ball, I should go round the other way. I should come from here, and I should literally just go round like that, because that's the ball.
I think you're misrepresenting what the website's telling you. And actually, so I knew where you were going.
How can I miss?
No. So I'm not going to get into it because there's like I said, I'm not a scientist. I'm just, what I like about
you're just indoctrinated.
This is two normal guys that don't have any kind of
not a clue
in science or anything like that. We're just debating what seems logical to us and makes the most sense.
And
there are videos out there that proves through flight tracking and the time it takes to get from destinations that the flat Earth would not make sense on the flight paths that they take.
Right, but there's videos out there of flight tracking.
What I'm questioning whether that arc is showing the plane going up and down rather than the plane going. I don't know. I'd have to look into that myself. So that's full disclosure. I can't say that that's not right and that's not wrong because I don't know. That could be the exact flight path that a plane takes to get from to those destinations.
Well, that is because I googled it, and Google's full of right.
That there's a lot of videos out there that shows that uses planes as proof that the Earth is round.
And there's also a lot of videos out there that uses planes and interviews with pilots, mind you, as well. Interviews with pilots that turn around and say the Earth's flat.
Right, so there's one pilot that's ever said it, and it's actually come out.
Not one pilot.
Proof. There's one pilot.
Not in a month of Sunday.
He was lying about it.
Okay, so if he's going around the globe, he's got to hold his nose like that.
That's a whole different.
But by the time he gets round there, he's upside down.
Here we go.
Right, anyway,
here we go.
Let's end it there,
What's
Craig.
What's upside down?
I don't know. I haven't watched Stranger Things for ages. It takes me into a different dimension. You ain't getting out of me. Anyway, right. Join us again next Monday, guys, as well as we'll probably do another one then, to be honest. What are we going to talk about next week? Anyway, Craig, come on, because we could be here all day on this one. What are we going to talk about next week? What should we bring into the equation?
Should we keep it on the theme of space for a bit, or should we go into something else?
I want to go to something else, and it's an interesting topic, actually.
Okay. Oh, I'm dread to think what you're going to go.
What? I've been looking into what we've been doing, and I've been looking into conspiracy theories. And one of the most interesting conspiracy theory that I think you'll like, okay, the Beatles. How many members of the Beatles is there?
Fab Four.
Fab Four. All right.
Is this
Paul
McCartney?
Paul McCartney died in 1966.
I'd love to talk about that.
Right, we're going to do that one. We'll go into Paul McCartney next week. Is he dead? Did they bring in a body double? I've got videos that show Paul McCartney to show that apparently Paul McCartney dropped himself in it on an interview, which basically creased me up because he literally turned around and he went, "Well, if I was him anyway, I would have earned millions by now. So where's all my money?" And I'm like, hold on. Apparently, you are him. Anyway, so we'll go into Paul McCartney next week as well, guys. Thank you so much for joining us. Don't forget, like, subscribe, turn on the bells, and absolutely hilarious things. Basically, me and Craig haven't really decided anything. He don't care if it's flat. I don't care if it's round. And to be honest, neither of us are actually going to know because, let's face it, we get sent fake stuff in the news every single day. So we're going to sign that one off, guys, as well. Thanks so much. For now, next week, see you later.